So today I'm going to talk about a very important topic here, which is hydrogen bonding. Now, what is hydrogen bonding? Let's initiate it, and with the help of an prototype that we can keep in our mind. A prototype may be a sample, so which we will solve all the questions that is related to hydrogen bonding. Right. So today's topic is hydrogen bonding. As you can see here in the picture as well. Focus on the picture. So today's topic is hydrogen bonding. Right. Hydrogen bonding. Okay. So let's go. Hydrogen bonding. Let me change the color of marker. So I consider that there is an atom A. It is linked with the hydrogen, something like this. So this atom, the criteria this atom should follow is this. First of all, it should be electronegative. It should be electronegative. The second thing, it should be small in size. Small in size. Instead, it should be and it should be whether it can be fluorine or nitrogen or oxygen, and it can be, but it can be chlorine and carbon, but only in the case of organics. Remember in mind that it can be chlorine and carbon, but only in the case of when we'll be dealing with organic, right? So keep this thing in your mind. So let's go. Okay, so let's go. So this is molecule, but don't say that this is a hydrogen bond, because this is covalent bonding. Covalent between bonding between hydrogen and an atom A. This is the criteria that it should follow. This is covalent. Okay. So what happens? Okay, wait. Let me just write it. This is covalent. Covalent bond. Covalent means strong bond, right? So due to it is highly electronegative, it gets the partial negative charge when it attracts the electron shear pair of electrons, right? And it gets the partial positive charge. And when other electronegative with negative element, okay, so let's consider that this is a molecule B. This is a B molecule, right? So this molecule, this atom, I'm mistaken, this is slip of tongue only. This is a B atom, which is electronegative, and it has lone pair. When a lone pair of atom with a lone pair comes closer to this hydrogen partial positive attracts this lone pairs, and it creates a bond, something like this, which is weaker in nature also, but now this is hydrogen bond. This is covalent. Formation of covalent bond is very important in order to form a hydrogen bond, right? As you can see, this is a covalent bond, due to which they have gotten the partial positive and partial negative charges, and due to which the hydrogen is attracting the lone pair of electron, which is given by the this atom B. So this is hydrogen bond. Now this is hydrogen bond, right? Always remember that this is hydrogen, dihydrogen, this is hydrogen, this is hydrogen bond. This is hydrogen bond in nature, right? So yeah, this is hydrogen bond, right? We know the certain things that I'm gonna write the points so that you should keep in mind that the hydrogen bond is less than covalent or ionic, and ionic, but greater than van der Waals forces that we have studied: ionic dipole interaction, instantaneous dipole and dual dipole. These all the forces that we have studied previously, the van der Waals forces, right? So yeah, this is something that you must keep in your mind while dealing with the questions. So the hydrogen bonding, covalent bonding, but then wonderful forces. So the energy of hydrogen is between 8 kilojoule per mole, 8 kilojoule per mole to 84, I think something like this, like 84 or 24. Let me just confirm it. Okay, let me just confirm it. Is it's 84 or 24? It's 42 kilojoule per mole. So this is basically, you should keep in this point in your mind while dealing with the question. So let's move up again and let's erase it because I don't think so now. Okay, so this is fine. So let's erase it. While now it's time to deal with the questions. So let's deal with the questions. Now you can keep this thing in your mind that how we have to deal with the questions. So I think we have gotten the space here, so I can continue here. So let's go. First question is, okay, so they are asking that is it possible? Is it, so you have to answer it. Is it possible? Okay, for a while now, first for the question solvent, let's create this molecule here and then we will look at it again and again, again and again for the answer. This is A, okay, not molecule but the sample here. This is hydrogen, this is a slip of tongue only, I'm consecutively saying molecule. Sorry, so this is B, okay, this is X, we can call this bond as X bond or we can call it as Y, okay? So keep it this thing in mind. So let's deal with the questions now. So is it possible that now the question arises? So let's write here. So number A is that bond energy of X is greater than bond energy. So let me just give the space here. So bond, I'm only writing short full form for only once. Then so that you can have an idea what the short form means, right? So bond energy of X is greater than bond energy of Y. That's true. Bond energy, of course. I told you that covalent bond is the stronger bond, the hydrogen bond, but van der Waals is weaker than hydrogen. So bond energy of Y. So it's pretty obvious thing. Right. So let's deal with other bond energy of X. Is it possible? Bond energy of X is equals to bond energy of Y. Bond energy of Y. Is it possible? Yes, it's possible. In 99 cases, this is true. 99 cases. This statement is perfectly true. This is statement. I'm just underlining it. This statement is true in 99 cases, but only one case, this statement is true as well. Only for the one person, this statement is, oh my god, this statement is true for one case. In which case? In this case, look, HF2. The bond energy of X become equals to bond energy of Y, HF2 minus, right? So this is something like this. What happens in this bonding and thing? Let's discuss it. For example, this is an electronegative element, fluorine, making bond with hydrogen, which is electropositive in nature. Not, yeah, after losing the electron or partial charges, electronegativity is very less. Hydrogen's electronegativity is very less. This is negative. So what happens? This fluorine, which got in a minus charge, there is a one more fluorine molecule and it has lone pair. So what happens? The hydrogen, which has got in a partial positive charge due to the fluorine attracts the hydrogen electron toward itself due to high electronegativity. So this fluorine gets attracted by this hydrogen and they create a bond between them, something like this. Something like this. So this is basically a covalent bond. Covalent, for a covalent I'm only writing C. This is hydrogen and H. So the point comes where the bond energy become equal, which is 200. It is 200, which is covalent, and it is 200, which is hydrogen, 200 kilojoule per mole. 200 kilojoule per mole. Kilojoule per mole. So their bond energy becomes equal. Their bond energies become equal. So there is a point that we can say that this statement is true only for the one case. So let's write it here. True, but only for the one case. Right, so this statement is true. Let's erase it and let's deal with other question. So let's erase it. Okay, so this is also looking messy here. Let's move up here. So this is sample. Oh my god. Let's write this A because it has been A. This is X and this is Y. So let's deal with the other question. So just I'm explaining with the concept with the help of question so that you can have an idea okay which statement is true and what's the reason behind it, right? Is it then they are asking that is it okay which hydrogen bond is strong? Now you have to answer which hydrogen bond is strong in nature. So they have gotten 3 molecules here in nature. Okay, let's get so let's get a highlighter for it. So I'm using this. Okay, let's use yellow. So it's prominent. So the first is T. Yeah, I think it's light. Is it visible? Yeah, it's visible. So first is hydrogen, and then fluorine, making a bond. And movement is from this is something like this 2 moles to negative partial, positive partial. I think I should change the color because it's not coming. Then one more hydrogen and fluorine. So we can deal with we can use this marker only for this example, and I'll change it. Okay, positive, negative, positive, partial positive. I think I might have mistaken. This is positive, and this is negative. This is positive, and this is negative. So what happens, right? So they are making a bond here, which is hydrogen bond. As you can see, this is okay. Let me change the marker. It's very loud. Let's take this marker. Okay, this is a covalent bond. Covalent. This is hydrogen. So then now the next, which is water structure. It's something like this: H, O, and then O, then H, then O, then again O. So they are also making the bond here. And the last molecule, ammonia. I'm making here ammonia. N, H, H, then again N, H, H. So here is covalent, while here it is hydrogen bond, which I have shown by dotted lines. So now which one is correct? This, or this? So let's see the explanation here. Then we will move up for the answer. So as we have seen here that to the sample that we have made up. So let me make it again. This is A. Focus here the concept. This is H. This is B. As I have said that okay, so that's right. Yeah. So as I have said that this is X and this is Y. So the strength of hydrogen is directly proportional to A, which means the electronegativity of A. So let's see that which has a higher electronegativity here. So as you can see here, fluorine. This is A, this is H, this is A, this is H. So here fluorine has a high electronegativity and smaller in size. This has high electronegativity but less than the fluorine. And yes, nitrogen do have high electronegativity as well but less than the fluorine. So here the right answer that we have gotten is this. This is basically a right answer. This is the right answer. So I've gotten I've given you the example or the concept behind what's the concept behind it. So